Okay, so already actually I had discussed that k-means algorithm. So what is that the first step? First step was that you need to select the k value. K value is the number of clusters that you need to take. Then you have to select random k centroids. If you are deciding that there are 3 clusters, then you need to take 3 centroids. Okay, those 3 centroids can be any data point, 3 data points you can take as a centroid, or any new data point can be selected as the 3 centroids. Then we will assign each data point to its closest centroid. Okay, closest, what to find out that closest, that I will tell you, right? So we need to assign each data point to its closest centroid. If any data point belongs to that is closest to C1, it will belong to C1. If it is closest to C3, it will belong to C3. After assigning each data point to the centroid, we need to find out the new centroid of each cluster, because the centroid of different cluster may change. So we need to find out the new centroid. Okay. After this, we need to repeat these steps. If any reassignment is occurring, that means we need to repeat the step. If there is no reassignment means if data points are not changing, if your centroids are not changing, that is that is the endpoint, or that is the termination criteria, this one, if there is no reassignment. Okay. So I will take this example I had already taken. If you want, I can take one more example. Suppose these data points are given to you and you need to make the clusters of that. First of all, I need to find out the value of k. Okay, suppose I'm taking the k as 2. So if k is 2, that means there are 2 clusters that I want to create. So first of all, I need to take 2 centroids. Suppose one centroid I'm taking is this one, another centroid is this one. Then second step is that we need to find out the distance of each data point from these clusters. Like if this data point is close to this one, then you can say that it will belong to this cluster. If this is more close to this one, you will say this belongs to this cluster. Okay. But in this example, what's the criteria they have taken to find out the clusters? You can join these 2 centroids by a line and then take a perpendicular line to this line. Okay. All the data points that are above this line, you can say they belong to blue centroid or blue cluster, and all the data points that are below this line, they belong to this one, orange cluster. Okay. So you will be having 2 clusters like this. So what is the next step? Next step is that the centroid of this cluster, we need to again find out the new centroid, because the centroid of this cluster will change. Okay. Again, what is centroid? That is the mean value. Suppose the centroid will change to this new centroid is this one, and this will also change. Suppose the new centroid of this is this one. Okay. So I need to find out the new centroids of these 2 clusters. You can see those are changed now, this one. Okay. After changing the centroid, again, there may be some data points now. Initially, they may be close to this one, but now they may be close to the orange one. Okay. Like over here, you can see once this data point is changed, I'm making this one. Suppose the new centroid is this one for the blue one. Okay. Now, initially, this data point, it belonged to this cluster, the orange one. But now when you will find out the new distance, you can see it is more close to this as compared to this one. So you can say this will now belong to the blue cluster. That means the cluster value will change. Grouping of these data points may change. So you can see over here that these 2 blue points are now more close to this one, and this orange one is more close to this blue one. Okay. So we will change the cluster values. It will become like this. Again, you need to find out the new centroid. New centroids are like this. Again, you will find out the membership of each data point. It may change. Okay. Then again, new centroids you are finding. And this would be your final 2 clusters. Okay. After this, there won't be any reassignment, or your centroids are going to remain same. So you will be getting these two clusters. Okay. So I think the basic idea of this is clear to you. Okay. Before taking this, that how to find out the value of K and what is the distance metric, I'll take one example. Okay. Like even like if you may get these types of numericals as well, that you may get this A1 and A2 are your data points, and you may be asked that cluster them using the k-means clustering algorithm. Okay. So I will take this example. What are A1 and A2? These are two features. Okay, it can be anything, like this is pose X, this is Y, some values are given, some float values are given for A1 and A2. We need to cluster them. So first of all, if you will draw a scatter plot, okay, along X-axis, like there is A1, and along Y-axis, there is A2. These blue points are your data points. These data points are being displayed over here. Now we have to cluster them depending upon that how many clusters we have to create. Okay, so that thing we have to do using now numerical. So first of all, first thing according to the algorithm was that we need to decide the value of K, and suppose that value of K I'm taking as is 3. Okay, so K is your 3. What is the next thing that we need to decide? First thing is that I'm saying that all these data points I will divide into 3 clusters. So K value is 3. That was the first step. Now the second step was that we need to take 3 centroids. Okay, so what I had told you that there are different methods to take the centroid. You can take any 3 data points as the centroid, or you can take any new value that is within this range, suppose 0 to 12 or 0 to 25, and suppose this one I'm saying this is your one centroid, this is your second one, and this is your third one. Okay, now in this numerical, this one, let me check, this is your these one. Okay, this is around 4 point something or 3.8. So this one you are saying 3.8, 9.9. Okay, this one is your this one. This is your 6.2 and 18.5 and 7.8 around, I think, no, not this one, 8.2 and 4.5. Okay, these 3 are centroids. Let me check for the next slide. It is written. This one, 3.8, 9.9, 7.81, and the 6.2. 7.81. Okay, this one. So these 3 are my centroid. This is suppose C1, this is C2, and this is C3. Okay, so I'm not selecting the new data points as a centroid. From these data points, any 3 are being taken as the 3 centroids. Okay, so what are the 3 centroids that we are taking? Those are written over here. First is 3.8, 9.9. So this one 3.8, 9.9. Second one is 7.8 and 12.2. Okay, so this one 7.8, 12.2. And your third one is 6.21. So 6.2, 18.5. So these 3 are being selected as the 3 centroids. Okay, so that was the second step. Now what is the third step? Third step is actually that we need to find out the distance of each data point from all these 3 clusters. Like I need to find out, this is post cluster C1, this is C2, this is C3. I need to find out what is the distance of all these data points from cluster C1 as well as from C2 and C3. Okay. Now suppose I'm taking this data point. I will find out the distance of this from this point, from this point, and from this point. And now you can see that this data point will belong to this cluster. Why? Because it is more close to this one as compared to this and this one. Now the thing is that how to find out this distance. Now in order to find out this distance, we will use the Euclidean distance. Okay. This distance metric is being used. You can use Manhattan distance also, but over here we will be using Euclidean distance. And already I think I have discussed this many times, that how to find out the Euclidean distance. Like if you are having two data points, x1, y1 and x2, y2. If you want to find out the Euclidean distance between these, what is the formula? Formula is x2 minus x1 whole square plus y2 minus y1 whole square. Okay. If you are having y2 minus y1 whole square. So this way you need to write down. Okay. If you are having, here I'm taking, there are two features. If you are having more than two features, like n features, the formula will become like this one. Okay. q1 minus p1 whole square plus q2 minus p2 whole square, so on, qn minus pn whole square. Right. Here I'm taking that there are more than one dimensions, like there are n dimensions, n features, like you can say. Right. So this formula already you know that how to find out the Euclidean distance. So once I have selected C1, C2 and C3, I need to find out the distance of each data point from C1, C2 and C3 using what? Using the Euclidean distance metric. Okay. So that I have done over here. Suppose in this table it is written. Like for what is the first data point? First data point is 6.8 and 12.6. Okay, and what is D1? D1 is that what is the distance of this data point from cluster C1. D2 is what is the distance of this data point from cluster C2. And this D3 is what is the distance of this data point from cluster C3. Okay, like one I have done in this. This is from 3.89, this one. This is 3.8 and 9.9. That means what is the distance of this from cluster 1? Okay, so in order to find out what is the distance of this from cluster 1, so what was the cluster 1 dimensions? That is 3.8, I'm writing over here, and 9.9. So if you want to find out what is the Euclidean distance of this data point from this cluster, you will use this formula. What is A1 value? 6.8 minus 3.8 whole square plus 12.6 minus 9.9 whole square. So when you will find out the value of this, it would be 4.0. Okay. Similarly, you need to find out what is the distance of this data point from cluster C2. So in order to find out that, okay, what are the dimensions of cluster C2? 7.8 and 12.2. So here you need to write down 6.8 minus 7.8 whole square plus 12.6 minus 12.2 whole square. So what you will be getting? You will be getting 1.1. Similarly, you need to find out the distance of this from cluster C3. What are the dimensions of cluster C3? 6.2 and 18.5. So you will write down 6.8 minus 6.2 whole square plus 18.5 minus 12.6 whole square. And then you will find out the square root of that. You will be getting 5.9. Okay. So you need to compare now these three. That means this data point is having the distance of 4 from C1, 1.1 from C2, and 5.9 from C3. Out of these three, which one is minimum? This one. That means here I'm saying this data point belongs to cluster C2. Is it clear? Yes. Any doubt in this? Is it clear how to find out that how each data point is belonging to each which cluster? whether it belongs to C1, C2 or C3? Yes, Nitika. Gurpreet Singh. 63, is it clear? Okay, Himanish, you have written now it is cleared. That means previously it was not cleared. Okay, Navneet.
Yes, हम कल से नहीं बनाएंगे।
Navneet Kaur, is it okay? Okay, fine. So similarly, you need to find out that this data point belongs to which cluster. So you will find out D1, D2, and D3, and you will see that this one is minimum. That means this is more close to C1 as compared to C2 and C3. So you can write down this data point belongs to cluster 1. Similarly, this data point belongs to cluster 1. So for each data point, you need to find out like this, okay? And if you will draw a like graph, it would be like this. Right now you can see like all these data points, they belong to cluster C1 because you can see there are many data points that belong to cluster 1. Only these 4 points belongs to cluster 2. This one, 1, 2, 3, and 4. Fine. And these 3, 1, they belong to cluster C3. These 1, 2, and 3. Only these 3, they belong to cluster C3. Okay, so that was actually the second step according to the algorithm, that what we are doing, we are finding that to which cluster our data point belongs, whether it belongs to C1, C2, and C3. So what is the next step now? Next step was that you need to find out the centroid of each cluster, because if you will take this C1 now, this cluster, centroid of this is not this one. It will change. Even the centroid of this will change, and even for this one may change. Okay. Now, how to find out the new centroids? For that, what we need to find out, suppose I'm taking for C3. Like you need to find out which data points belongs to C3, this one, and these. These 3, they belong to cluster C3. Okay, these 3, they belong to cluster C3. Now I just need to check that what is the new centroid for this cluster. So in order to find out the new centroid, okay, like already I told you what is centroid. Centroid is the mean value. So what you will do, you will take the A1 value, you will find out the mean of these 3 and mean of these 3. Or to find out the mean of these, this would be your 6.0. Okay, I have done that in next slide. This is 6.0 plus 6.2 plus 7.6 divided by 3. Similarly, for this one, it will be 19.9 plus 18.5 plus 17.4 divided by 3. So whatever value you are finding, that is your new C3. Okay, so I will show you that. I have done for C3, this one. Okay, so this is 6 plus 6.2 plus 7.6 divided by 3. So what is the mean value that you're getting for A1? That is 6.6. And what is the mean value for A2 that you're getting? 18.6. So for C3, for third cluster, the new centroid is changed now. Okay, new centroid, previously it was this one, now that is changed. It is 6.6 and 18.6 now. Is it clear how to find out the new centroid? So this was the old value and this is the new value. That means the old centroid was this one. Now the new one is this. For C2, the old value is this one. The new is this. Old value is this one, but the new value is this. So the centroid is changed. Similarly, you will find out the centroid for C1 and C2. Like how to find out for C2, you will check that what are the different clusters, data points that belong to cluster 2. Okay, this one, this, and this. You will find out 6.8 plus, you will say 7.8 plus 8.4 plus 9.6 divided by now 4, because there are 4 data points. Similarly, 12.6 plus 12.2 plus 6.9 plus 11.1 by 4. So new centroid will become 8.2 and 10.7. Similarly, you will do for C1. Okay. So once you're having the new centroids, again, you will check what are the distances of all the data points again from C1, C2, and C3. Okay. Again, you are finding that what are the distances of different data points from all these three clusters. Fine. And if there is any reassignment, suppose previously one data point belonged to C2, now it may belong to C1. You need to find out the minimum distance. After doing that, again, you need to find out the new centroids. So this step is being repeated until there is any reassignment. While if you're not getting any reassignment, then you can say that this is the last step. Okay, so after second iteration, you'll be getting this one. These are the new clusters, C1, C2, and C3. Is it okay? So this is your C1. This is now your C2, and this is C3. Now, again, if you will find out the distances of these data points from C1, C2, C3, it won't change. It will remain same. That means this and this is going to remain same. So you can stop over here. Okay, so you can say this is the final clustering. All these data points, they belong to C1, they belong to C2, and these belong to C3. Is it clear? That means we are stopping even after just after the second iteration, but it depends on the data points, the data set that is given to you. Sometimes there may be like 3 iterations or 4 iterations that we need to check. Fine. Yes, any doubt in this numerical? If it's clear, please write down in chat box. Okay. Okay, fine. Pavan, Himanish, Ashley, fine. Kanika. Okay, next thing is that, like in algorithm, we had written that the first thing is we need to decide what is the value of K. Select the number K to decide the number of clusters. Okay. Now, how to find out that what is the optimal value of K? Because if you are taking K as very less, if in your data set, suppose there are thousands of data points and you are just taking that you want to make 2 clusters, then your accuracy will not be very high. But if K is very large, in that case also you can say that your clustering is not very good. Okay, so we need to find out that what is the optimal value of K, which value of K you should take. So that is actually the disadvantage of K-means algorithm, because in K-means, first of all, we need to decide that what is the value of K or how many clusters I need to create. That is the biggest disadvantage of this K-means algorithm. Okay, but anyway, if we are using this K-means algorithm, how to find out that what is the optimal value of K? For that, we will use the ALBO method. Okay, now what is that ALBO method? In this case, we will find out that what is the value of WCSS. WCSS is that within cluster sum of squares. Okay, within cluster sum of squares. That means within a cluster, we need to find out that how much variation is there. Fine. So what we need to do, suppose if I'm deciding that I have to take 3 clusters, value of K is 3, then I will find out that what is the value of WCSS? That means in this cluster, how much variation is there? In this cluster, how much variation is there? And within this, how much variation is there? Now, how to find out that within cluster sum of squares value? Within this cluster, suppose if there are different data points, I will take the distance of each data point from the centroid and I will take the square of that. Then plus again, I will find out what is the distances of different data points from the centroid of cluster 2, and again I will take the square of those. Similarly for the third cluster. That means I'm taking the summation of all these three. That is your WCSS value. Okay, so what it is giving you? It is giving you that what is the sum of square of the distances between each data point and its centroid. So we want that that distance should be minimum. We are finding what is the distance of each data point from the centroid of C1, distance of another data point from centroid of C1, and we are taking the square of that. Then similarly for C2, we are finding the same thing, and for C3, we are finding the same thing, and we are taking the summation of that. Okay, if there are three clusters. Similarly, you will take the value for K as 2, K as 4, 5, 6, 7. Like for this different values of K, you will find out that what is the value of WCSS. And that is also called the inertia. Okay, when I will do the practical part, there is one feature that is called within this K-means algorithm that is called inertia actually. So inertia is what? WCSS. So for different values of K, actually you need to find out WCSS. Okay. Then I will plot a graph. That graph is between the number of clusters that I'm taking and the value of WCSS. That means over here, suppose I have taken the value of K as 1. That means I'm saying I just want to make one cluster. In that case, the value of WCSS is very high. That means this is the error, like you can see, that is very high. When K is 2, it will become less. It is around 4,000. When it is 3, when I'm taking K as 3, it is very less. It is around 900. After that, although it is becoming very less for 4, for 5, for 6, 7, 8, 9, 10 like this. That means for K is equal to 1 to 10, I'm finding the value of WCSS for different value of K, and we are plotting a graph. Okay. Now, what is the optimal value of cluster? You have to find out that in this graph, where you are getting the sharp band. Okay. Sharp band is over here. Like here, the value of WCSS is being decreased, but here it is decreasing to a very low value. So this you can see is a sharp band, and this is your optimal number of clusters. Okay, like for this example, you can say what value of K you should take. The value of K that I should take is 3. Optimal value of K is 3. I shouldn't take 1, I shouldn't take 2, even although the value of WSS is low in case of 4 and 5 or 6, but this is the optimal value. Okay. Now, why this is called the elbow method? Because you can assume like this is like your arm and there is an elbow. Okay. Suppose you have bent your arm. When you will bend your arm, this is representing your elbow. Okay. So you can compare this graph with your arm, and you have to take the optimal value of K that is being represented by this elbow, because this is representing the elbow of that graph. That's why this is called the elbow method, right? So even during practical part, I'll be creating this graph and I will tell you that which value of K I should take. So how to find out the value of K, optimal value of K, or how to find out that how many clusters I need to create. For that, we need to find out the value of WCSS for different value of K. Suppose you can take K as 1 to 10. Sometimes you need to take 1 to 20. For different values of K, find out the value of WCSS. Then plot a graph Along x-axis, you can take K, and along y-axis, take WCSS. And then find out that what is the elbow of that graph. Okay, suppose it is like this. The elbow of the graph is over here. That means this is the sharp point of bend. Find out the sharp point of bend, or the point of the plot looks like an arm. Then that point is considered as the best value of K. So this is being considered as optimal value. Okay, so this way we will find out the optimal value of K. Fine. So this is how to find out the value of K. Other thing was like this thing I had already told you, that how to find out the distance of each data point from the centroid. So mainly used method is Euclidean distance. So I have taken that one only. Okay. And this one also I have told you, just for this numerical, actually I had written that how to find out the new centroid. If you want to find out the new centroid after this one, if you want to find out the new centroid, you need to take all these values and take the mean of that, take all the values of A2 and take the mean of that. Just that thing I have written over here. Okay. Okay, any doubt? Then I will take the advantages and disadvantages of this K-means algorithm. Any doubt? Okay, like there are other clustering algorithms also, like I had told you in your syllabus, you're having the hierarchical method is there and density based methods are also there. Okay, so what are the, all these three are having their own advantages and disadvantages. Now, what are the advantages of K-means? First thing is like it works well for large scale data. Next one is that it doesn't make any assumption about the data, that your data should be normally distributed or any another distribution should be there. So that thing is not there. It doesn't assume any distributional assumptions. Okay. Next is that it is easy to implement as compared to the other algorithms. Other clustering technique means as compared to DBSCAN, that is a density based and hierarchical method, it is easy to implement. Okay. But this algorithm is also having some disadvantages. Like one disadvantage, I have already told you that we need to specify the number of cluster in advance. So that is the main disadvantage of this K-means clustering algorithm. Fine. Another thing is that it can't handle outliers. Like if your data is noisy, if there is noise or some outliers are there, then it becomes difficult for this algorithm to handle those. And the third one is also very important disadvantage, that it is not suitable to identify the clusters with non-convex shapes. Okay, now what's the meaning of that? Suppose you have been given a data set, and if you will plot the scatter plot, you are getting a scatter plot like this. Okay, like from this scatter plot, actually we can say there are two clusters. One is this one, because all these data point belongs to this, and the another one is this one. But if you will use K-means algorithm, it will find out two clusters like this way. It is saying this is your cluster 1 and this one is your cluster 2. But actually this is wrong. Okay, so K-means algorithm can't be used for these types of data points. Like if you're having non-convex shapes, even I will tell you again some other, like these shapes also, it can't be handled by this. Suppose there are some clusters that are over here and there are some data points that are over here. This type of clusters can also, we can't find out by using the K-means algorithm. So it is not suitable for non-convex. These are called the non-convex shapes. Is it okay? So these are the disadvantages of K-means algorithm. So if there is one more slide, same thing I have written. So if some question is coming over just K-means, like what do you mean by